Hello everyone. In this session, we will see about a binary tree and then how can we implement a binary tree using a linked list. A binary tree is an type of an trees, okay, which belongs to the data structures. So where here, always it can consist of a root node or a root node with a single child or two child. That's a maximum of two child. So that's a binary. Binary means what? Two. The at most two children should be there. Maximum can be two children and minimum can be a single node. That's a binary tree. So these are the different types of binary trees you can see here. Yeah, for A, the two children are B and C. Maximum of two children. For B, there's a single child. For C, there's a single child. And for D, there is no child at all. So this is a type of this belongs to binary tree. So now here A is having a minimum of one child and B is having minimum of one child. So it's a binary tree. C is having a one child binary tree. So whereas here also is everybody having a maximum of two child or minimum of one child or minimum of a single node. So these are called an type of an binary tree. So when will you call them as a similar binary tree? So the structure will be same, but the data will be different. So here the structure is same. A is having a two child and C is having a single child. So one is having a two child and three is having a single child. The same structure, but I have used different datas. So this is called similar binary tree. And copies of binary tree just replica of a single another one tree to another tree. That's a copies of binary tree. And when will we call a binary tree as a complete? So always we will store the data by means of left to right, left to right. So we are calling this tree as a complete. Why we are calling this tree as a complete? So here if you observe, A is having a B and C child and B is having a proper maximum of two child D and E and C is also having a proper maximum two child G and F. Then after this, D is filling the leftmost child H. Okay, so this is called complete tree. So if D is having a right child, then it is not a complete tree. Always you should fill the data from the left to right. Okay. So first left child and then right child, and then left child and then right child, left child and right child once again. So this is called complete tree. So why I am calling this as a not complete tree? So this is a level 0. A is having a root node. A is a root node. A is having two child B and C, and then B is having a two child. That's a D and E. But in the level 1 itself, if we observe, C should fill the left child first and then right child. But without having a left child, C is having a right child. So it is not a complete tree. Likewise, D is having left and right, correct. But here in the level 1 itself, always we should have a left child first and then right child second. But in this case, C is having a right child without having left child. So that's why we are calling this as a not complete tree. The same case here. A is having two child. Yes, correct. B and C. B is having a left child and then right child. It's correct. But C is having a right child without having a left child. So it is not a complete tree. So always we should fill the nodes from left child to right child and left child to right child. So we should check on all the levels. Even the level 1 is not not executed properly or not store the data properly, then it is not called as an not complete tree. So how can I represent using a linked list? So here in the linked list, in the structure, we will use always a structure. So in the structure, we having a single data field that is called A, and then we have two pointers. One is called left node pointer, and then right node pointer. So B is having a left node pointer and right node pointer. So here I will store the address of left child, and here I will store the address of right child. So for B, so the D address will be stored in the left child, and E address will be stored in the right child of B. And D is having an two child G and H. So the G address will be stored in the left child of D, and the H address will be stored in the right child of D. So since there is no child for G, it will be null pointers over here. There should be null pointers over there. So this is how we can represent a binary tree using a linked list. So now we will see the coding. How can we do it? So here you can observe we have formed a structure for a binary tree. So data field and then left child and right child. Why we are calling this as left and right? Because you can see here if a single node consists of a data field called A and then left node address and right node address. A left node address is for to store the left child and right node address for the storing the right child address. So that's why I have given as a left and right. So this is the corresponding structure for the binary tree. So and then we'll go to main function. So in the main function, when we are creating a node, when we are creating a tree, so at first there will not be any node. So initially the root will be equal to 0. Root will be equal to 0. So then I will give root is equal to create. Create is a sub function. Create is a sub function. So then what happens over here? It will call the create function. It will call the create function. This is the create function. This is the create function. So we'll see one by one. So in the create function, what happens over here? I have got a data through the variable called x, and then once again a new node, a local pointer has been created, new node, and then I have allocated memory space for the new node. So we know this already. So if you don't know means you please go and refer the linked list videos over there. So memory allocation function for the node. So the new node memory has been created, and then if there is no data, then we will enter the -1. Okay, so the prompt has been given as -1 for no node. Okay, so now what happens over here? We enter 10. We enter 10. So once you enter 10, what happens over here? In the variable called x, it will be get stored 10. So then if it will check if x is equal to -1, no, we have entered a 10. So the if function fails. Then what happens over here in the new node of data, x has been stored. So now what happens over here? That 10 has been stored as a root node. 10 has been stored. Then for a 10, we have a left child and right child. For a 10, it have a left child and right child. So I will ask the enter the left child of x. That's mean enter the left child of 10. Okay. So new node of left. Once again, it comes to over here. Okay, the new node of left means what? The new node of address of left will be the create function called once again. The recursive function. Same function, the create function will be gets created. Called once again. So then once again x. So for 10, yeah. So the second call has been you enter 20. So a new node with the data 20 is created. Okay. So what happens over here? Once again the 20 is added up. Then what happens over here? Once again to ask the enter the left child of 20. Okay, do you have any other left child of 20? Okay, so I'm entering 40. I'm entering 40. I'm entering 40. So once again, what happens over here? It will call the same function, create function once again. Once again, it will go to that new node of once again new node will be created, and then the new node of data to store the value called 40. So once 40 gets stored, then what happens over here? It will ask for the left child. It will ask for the left child. I'm entering -1. I'm entering -1. So then what happens over here? It will returns null. It will returns null because 0, right? So no, if -1 means it will return 0. So then it will resume from the where I have left. This is the function I have left, right? So it will go to the right child. Enter the right child of 40. So what's the right child of 40? I'm entering -1. I'm entering -1. So once again, what happens over here? No right child. So it returns null. It returns null. Returns node 40 as left child of 20. So it will comes back over here. So for 40, there is no left child and right child. So 0, 0. So for 40 is completely done. Okay. So then what happens over here? The function is here. So once for 40, left child and right child both is finished. So then what happens over here? It goes to the 20 of left child is 40. It has been here. So then 20 of left child is finished, right? So it goes back to the 20 of right child. So enter the right child of 20. Enter the right child of 20. So now here, so ask for right child of 20. I'm entering -1. So then what happens over here? It returns null. It returns null. So 0. So then 20, both left child and right child is done. So then what happens over here? It goes to the right child of 10 because it has been left child of 10 is 20 is completed. So it is go to right child of 10. So now it will goes and enter the right child of 10. So then what happens over here? Ask the right child of 10. So create is called once again. So I'm entering 30. The 30 is created. 30 is created. So then what happens over here? For the right child of 10 is 30. Then for 30, it will ask for the left child. It will ask for the left child. So I'm entering as a null, -1. I'm entering -1, it returns 0. So then once the 0 is done, it goes to right child of an 30. So then what happens over here? I'm entering 50. I'm entering 50. Okay, it will go for the right child of corresponding 30. The right child of will be gets 50. So then for 50, there is no left child, there is no right child. So the same function will be called again and again. The same function will be called again and again like this. It's by means of recursive function. So now what happens over here? This is structure, this is a program for construction of an binary tree. So whatever data has been created, the node will be gets created and then it will store the data. To store the data, and then at first it will enter the left child and the create function will be called. And then once left child is until -1 comes, the left child will be keep on filling up. And then once -1 comes, then it goes back to the right child of all the nodes, right child of all the nodes. So that's what we have done over here. Okay, so now what happens over here? At first 10, 10 left child of 10 is 20, and then left child of 20 is 40. So at first it will fill the full of left child. It's a recursive function, create, create, create. The same function will be calls, the same function will be called again and again. So then for 40, there is a -1. If return 0 comes, then it goes to the right child of node. Okay, right child of corresponding node. So then 0. Then once for left child, right child, both are gets finished for 40, it goes to right child of 20, 0. Then goes to right child of 10. Then 30 has been done. So for 30, what's the left child? 0. What's the right child? 50. So likewise, we can create a binary tree using a linked list.